I'm going to review a problem very much like 11.8 in the textbook because I think it illustrates several important concepts in using normal distributions. So recall that 11.8 in the textbook addresses bladder cancer in women. So let the variable x represent bladder. Did I say bladder cancer? I meant bladder capacity. And we're told that distribution of that random variable is approximately normal with a mean of 400 and a standard deviation of 75. You'll recall the notation we use. We put the value of the mean mu first and then a comma and the value for the standard deviation of the distribution second. So this is for women. And in an earlier problem, we're told that men, maybe I should use a different color for men. And then for men, bladder capacity is also normally distributed. And let's call this variable y, this random variable y. But that they have a larger bladder capacity and they average, is it 550? And they also have a greater standard deviation. We'll just ignore the phone for now. Okay, so how does this look like on a curve? So here's the normal curve for women, and so it's centered on 400, right? And then the standard deviation, which is the distance from the middle of the curve to the inflection point, we're told is 75, right? So therefore, if we follow this down here, this must be a value of 475, and then one more standard deviation unit over to the right, that's 550, right? Now in comparison, men have a mean of 550, so let's go back to the blue color. Right. So their curve is a little wider because it has a bigger standard deviation. It's going to be very hard to do that accurately. But we know for sure it's to the right. And once again, this is a terrible normal curve. But I'm not very good at this yet. Right? So you can see that the curves overlap, and it's not accurate how much they overlap here. It's very inaccurate. But you can see that the men's distribution, right, is to the right of the women's distribution. And then if we go one standard deviation to the right in men from their center, that should be about 650. So this is not drawn to scale, but it's just giving you an idea of where the two distributions sit relative to each other. So let's return to the distribution of bladder capacities for men, and let's ask the question, as 11.8 asks it for women, let's ask the same question for men. We're going to ask what proportion of men, or what's the probability of finding a bladder capacity in men that's less than 600 but more than 500. So we should always start by drawing the curve, right, as best of our ability. Sorry for the lousy curve. Right? And then let's say the inflection point is there, not really accurate, but we're going to say that's a value is about 100 in width. So if that's 550, this must be 650. And if we go down one standard deviation to the left, that must be 450. Right? So we're being asked what proportion of men fall between 500, which must be halfway between 550 and 450 and 600, right? Right. I'm really sorry about the sloppiness of this curve. It's very hard to draw on this pad for me still. So we're asking how that corresponds to this area under the curve between 500 and 600, right? That's 500 there, and that's 600 here. So what must be done? We need to convert these numbers to a z distribution. Remember, for d distribution, z's always have a normal distribution with a mean of 0 and a standard deviation of 1. So that's centered on 1, and now we have to find these landmarks on the z distribution. Right? So to do that, we simply standardize the two values. So the lower limit, call that z1, that's equal to 500 minus the mean, which is 550, over the standard deviation. Right, so that's equal to 1/2, negative 1/2, or negative 0.5, and then the upper limit that we need to find is z2. We'll call that z2. It's going to be 600 minus the mean of the distribution over the standard deviation. That is going to be equal to positive 0.5. So we're looking for the area under a standard normal curve between negative 0.5 and positive 0.5. We go to the z-table to look that up. And we see the area under the curve to the left of negative 0.5 is 0.3085, and the area under the curve to the left of positive 0.5 is 0.6915. Right? So using that trick I introduced at the last lecture, this value is going to be equal to the area to the left of the higher value minus the area under the curve to the left of the lower value. Right, and that gives us 0.3830, or 38.3%. So the answer to the question is, what percentage of men have a bladder capacity between 500 and 600 cc's is 38.5%.